Look up at the night sky, and you're staring into the vastness of the Milky Way, a galaxy containing hundreds of billions of stars, including our sun. But have you ever wondered, where did it all come from? How did our galaxy form? And what will happen to it in the future? The Milky Way is ancient, over 13 billion years old, but its story is still being written. Today, we're taking a journey through time to uncover the incredible history of our galactic home. Now let's start off with a recap of the early universe and the first galaxies. Our journey begins nearly 13.8 billion years ago, in the wake of the Big Bang. At first, the universe was a chaotic, hot soup of energy and particles. Over the next few 100 million years, the first atoms formed. You'll remember from my first video that these were mostly hydrogen and helium. These atoms clumped together under gravity, forming the first stars, then entire galaxies. But the first galaxies didn't look anything like the Milky Way. They were small, irregular, and constantly colliding with one another. Instead of elegant spiral arms, which you've seen in all the movies, these young galaxies were turbulent and chaotic. At this time, massive stars were forming and dying at an incredible rate, filling space with heavier elements like carbon and oxygen, which are the building blocks for future planets and life, and the planets and life that we know. So now let's talk about how our Milky Way formed and came to be. The Milky Way likely started as a small proto-galaxy, a collection of early stars and gas clouds. Over billions of years, mergers with smaller galaxies helped it grow. Each collision reshaped our galaxy, adding more stars and expanding its structure. But this wasn't a smooth process. Every time a smaller galaxy collided with the forming Milky Way, it triggered intense star formation, huge bursts of new stars lighting up the sky. And over time, these countless mergers transformed the Milky Way into the majestic spiral galaxy we see today. So what's at the center of the Milky Way? I'm not going to go too in-depth on this, because I want to save that for a different video. At the heart of our galaxy lies a monster, a supermassive black hole known as Sagittarius A. And I'm not talking about horoscopes, so if that's what you came here for, you can leave. This black hole has the mass of over 4 million suns and plays a key role in shaping the motion of stars near the galactic center. But black holes aren't just cosmic vacuum cleaners. They also influence the way galaxies evolve. In some galaxies, black holes actively feed on surrounding gas, producing high-energy jets that can shut down star formation. But for now, Sagittarius A remains mostly quiet. But astronomers are watching closely, waiting for the moment it wakes up. Now let's move towards the life cycle of stars in the Milky Way. The Milky Way isn't just a collection of stars. It's a stellar factory, constantly creating and destroying stars in a cosmic cycle of life and death. Right now, new stars are forming in massive nebulae, which are vast clouds of gas and dust scattered throughout the galaxy. These regions, known as stellar nurseries, are where gravity pulls gas together, igniting nuclear fusion and giving birth to new stars. One of the most famous stellar nurseries is the Orion Nebula, located about 1,300 light years away. You can actually see this one in the night sky if you have a telescope. And I guess you could say you could see it with the naked eye as well, but if you have a telescope, I really recommend checking it out. Anyways, but stars don't live forever. Smaller stars, like our sun, will burn steadily for billions of years before expanding into red giants, and eventually shedding their outer layers, forming a glowing planetary nebula. At the core of these remnants lies a white dwarf, a dense, hot stellar remnant that slowly fades over time. In fact, this is how our sun's life will eventually end, about 5 billion years from now. But for the most massive stars, their endings are much more dramatic. Instead of gently fading away, they explode in a supernova, blasting their outer layers into space and scattering heavier elements like iron and gold across the galaxy. These explosions are crucial for life itself, because without them, the elements needed for planets, atmospheres, and even our own bodies wouldn't exist. This stellar cycle of birth, death, and rebirth has shaped the Milky Way for billions of years. And right now, it's still happening all around us. Finally, what does the future of the Milky Way look like? Are we going to die tomorrow? Probably not. Our galaxy's past is fascinating, but what about its future? The Milky Way is constantly evolving, shaped by gravity, stellar life cycles, and cosmic interactions. One of the biggest challenges in the Milky Way's future is its collision with the Andromeda Galaxy, our nearest galactic neighbor, which sits about 2.5 million light years away. So what does that mean for us? Right now, Andromeda is hurtling towards us at a speed of 110 kilometers per second, or about 250,000 miles per hour. That might sound really fast, and it is, but based on current estimates, the two galaxies will collide in approximately 4.5 billion years. But here's where things get interesting. This collision won't be as catastrophic as you might think. Even though both galaxies contain hundreds of billions of stars, the sheer amount of empty space between them means that very few actual stars will collide. Instead, their massive halos of gas and dust will interact, triggering an era of intense star formation. Over the course of millions of years, the galaxies will pass through each other several times, distorting their spiral structures into chaotic, stretched-out shapes. Eventually, gravity will pull them together into a new, larger galaxy, a massive elliptical galaxy that scientists sometimes call Milkomeda. No, don't hate me, that's actually what they call it. Our night sky might look completely different during this time. Instead of a faint band of the Milky Way stretching across the sky, Andromeda will appear as a massive, bright, glowing structure, visible to the naked eye, before slowly merging into our own galactic core. But what will life on Earth look like when this happens? Now that's harder to predict. By this time, the sun will have already started its transition into a red giant, which could make Earth uninhabitable and pretty much destroy us all. But if humanity has found a way to survive, our descendants could witness one of the most extraordinary cosmic events in history, the birth of a new galaxy. Now buckle up for the longest conclusion you've ever heard. The Milky Way has been evolving for billions of years, and it will continue to transform for billions more. From its formation through galactic collisions to its eventual merger with Andromeda, our home galaxy is part of a much larger cosmic story, one that's still unfolding. Even today, the Milky Way is constantly changing. New stars are forming, older stars are dying, and the shape of our galaxy is being sculpted by gravitational forces beyond our control. In a way, we're living inside a giant dynamic experiment in astrophysics, one that spans the entire history of the universe. But there's still so much we don't know. What other cosmic encounters has the Milky Way had in the past? How many undiscovered planets orbit stars in the outer edges of our galaxy? And will the eventual Milky Way-Andromeda merger give rise to new habitable worlds? These are questions that astronomers are still working to answer. And with every new discovery, we get a clearer picture of our place in the cosmos. Will humanity still be around when the Milky Way and Andromeda galaxy collide? Could we one day travel across the new merged galaxy? Let me know what you think in the comments. And if you enjoyed this deep dive, make sure to like, subscribe, and hit that notification bell for more space mysteries every week. Thanks for watching, and I'll see you next time.